Hey there, my name is Jerry Thor, and I'd like to welcome you to Descriptive Statistics. Over the next 10 minutes, we're going to discuss elements of this topic that include distribution, measures of central tendency, measures of variability, usage, and presentation. In exchange for just 10 minutes of your time, you're going to come away with a good understanding of this topic and why it will be incredibly useful to you as a researcher moving forward. Sounds good? Let's roll. Distribution is simply a list of scores taken on a particular variable. For example, judges at a slam dunk contest might provide scores of 6, 7, 7, 7, 8, 9, 10, and 10. A researcher can use this distribution and calculate three of what's called measures of central tendency. The first is called mean, commonly known as the average, and is found by adding them all together and then dividing by the number of scores. In our sample distribution, 8 is the mean. This is the statistic of choice for normally distributed data and can be found anywhere from your grade in this class to ratings in the App Store. One drawback of mean is that it allows very high or very low numbers to sway the outcome, as can be the case when analyzing categories like salaries and home prices. So what can we do if the data is skewed? Simply looking at the midpoint of the distribution can serve as an excellent measure of the center of a group of data known as the median. In our sample distribution, 7.5 is the median. And finally, we have the mode, which is the score that occurs in the greatest frequency. And while this is the least precise measure when it comes to central tendency, it can be helpful when discussing categories like population. In our sample distribution, 7 is the mode. Now that we've covered measures of central tendency, let's talk about variation. Variation can be found in every distribution and is a way to show how data is dispersed or spread out. Why is this important? Without knowing something about how the data is dispersed, measures of central tendency can actually be misleading. For example, imagine if 10 graduates of this program go on to positions with a mean income of $150,000 with little variation from the mean. That would be very different than if the mean income is $150,000, but 8 of the graduates earn $50,000 and 2 of the graduates become big shots, earning $550,000. Measures of variability therefore provide a more complete picture of the data set here and include three measures: range, variance, and standard deviation. Range is the distance between the minimum score and the maximum score. In our sample distribution, 4 is the range, computed by subtracting 6 from 10. Variance measures how far a set of random numbers are spread out from their average value. And standard deviation is a common measure of the amount of variation of a set of values around the mean, and is calculated by taking the square root of the variance. A low standard deviation indicates that the values tend to be close to the mean of the set, while a high standard deviation indicates that the values are spread out over a wider range. Let's compute variance. To compute it, first we need to calculate the mean. Then, for each number in the distribution, subtract the mean and then square the number. Finally, calculate the average of the squared differences. Another measure we can use is the interquartile range, which is the difference between the first quartile, which holds 25% of the values below it, and the third quartile, which holds 25% of the values above it. So now that we know how to determine the three measures of central tendency, as well as calculate the measures of variability, how do we know when to use what? And what are some of the best ways to present this information? Normal data falls on a distribution sometimes called the bell curve, where the data tends to be around a central value with no bias left or right. Calculating means and standard deviations are recommended here, and presenting it with frequency polygons, which connects points between categories, and box and whisker plots, which gives graphical representation of the distribution of scores. Ordinal data are the type of data in which the data values follow a natural order. One of the most notable features of ordinal data is that the differences between the data values cannot be determined or are meaningless. With this data, median and nonparametric tests are recommended. Researchers can present their information with frequency tables, which tabulates the number of occurrences of each level of a variable as well as a number of missing values. Also calculates the valid percent and cumulative percent for each level. Order of categories in tables is shown from low to high. Researchers might also consider frequency polygons and box and whisker plots. Unlike ordinal data, nominal data is a type of data that is used to label variables without providing any quantitative value. With this data, mode or count is most recommended. Researchers might consider presenting this data with frequency tables constructed by arranging collected data values in ascending order of magnitude with their corresponding frequencies, bar charts, which creates discrete, not connected columns to illustrate the frequency distribution, or histograms, similar to a bar chart, but removes spaces between the bars, indicates a continuous variable underlying the scores. That concludes this presentation on descriptive statistics. I hope you enjoyed it and found benefit, and best of luck to you in your statistical journey.